Hello everyone. My name is Hajed I'm Cloud Solution Architect at Proximus. I'm here with Jeremy today. Actually, we are coming from Luxembourg to share with you how we could develop a simplified and portable cloud-native architectures using Dapr. So first thing first, we are going to present the challenges behind building microservices. So we're going to start basically actually with the classic microservices approach. I know for some people microservices is a new thing, but there is a classic way in building microservices that most of people know, which is the way that you can see here. This is an e-commerce application that we did develop to demo today actually our solution and the way we did use Dapr to develop a simplified portable microservice architecture. As you can see, we've got 3 different microservices, and we've got the set of tools as external tools that we are using to for good inter-services behavior. So, I mean, now we've got some issues with this solution that simply we've got a tool-specific oriented configuration in each microservice. So in each microservice, actually, we've got specific configuration for Kafka, MongoDB, which is specific for that tool, which limits portability and which is complicated for developers, which turns the development of the microservices kind of hard for developers because they need to learn the programming language, the business model, the business specs, and also some set of tools outside of the application. I'm going to give the floor to Jeremy to explain for us how it's hard to develop microservices.
Thanks, Hajed. Hello, everyone. I'm Jeremy. As we can see on this famous post from Vlad, LinkedIn post from Vlad, building microservices today is bringing a lot of different components, affecting, increasing the complexity of the application and even affecting the responsiveness of your application. The maintenance cost is also increasing exponentially with the numbers of components you add to your microservice, and you are increasing the attack surface of your application by having to maintain and upgrade each specific libraries that are needed to connect to each external services. Okay, so I'm sure there are developers in the room. Can you raise your hands, developers, or people who used to be developers?
I'm a developer also.
Okay, keep your hands risen if you are a developer who can both develop the microservice or the application and integrate your application with Kafka.
Who knows Kafka? Keeps the hands up.
Okay.
Kafka.
Keep your hands risen if you are able to develop the microservice, integrate it with Kafka, and integrate connectivity with Keycloak.
Keycloak also.
Okay. We have no more hands risen. It means we are putting a burden on developers to master a multitude components, external components, to integrate it in the microservice. And that's bad.
Yeah. Actually, we are here to make it easy for you guys. So we are here to simplify this complexity. As Jeremy did explain, actually, nowadays, microservices is not just about the programming language. So in the old days, if you are a developer, okay, you're a Java developer or you're a Golang developer, and that's it. And nowadays, you need to learn a lot of tools externally outside of your microservice in order to develop your microservice. So actually, it's not a business-focused model, and actually it becomes fuzzy and complicated for the developers to develop the solution, and we need, in order to have a minimized solution and an efficient solution, to minimize those learning curves as much as possible, and to give an abstraction layer and to abstract and minimize all those complexity. I'm going to give an example. Nowadays, if a developer wants to send a message, he doesn't care if the message is going to be sent on Kafka or Amazon SQS or ActiveMQ or whatever. The goal for him is to send the message and to guarantee that the message is being received by the other side, by the other microservice. So we need to go from this view to this view. So we are going to have a provider that is going to abstract the view for the developer, which gives a good business focused development for the developer to concentrate actually only on the business model and to concentrate only on the efficiency of his code. Add to that, we offer portability across different platforms. With this model, if we are going to migrate from Kafka to the cloud, for example, using AWS SNS SQS or Azure messaging bus or whatever, it's easy because it's transparent for the application itself. So technically, how can we do this? As Linus Torvalds said, talk is cheap, show me the code. On the left side, you can see a Java application. This is a configuration actually just to send a message over Kafka using Java coding language. As you can see, it's so complicated and it's so specific to Kafka because we need to configure all the properties, all the SSL, all the serialization, the message itself. Then we need to create the producer and initialize it and send the message. On the other side, it's much more easier using the abstraction layer, using Dapr client. We are going to see Dapr in a minute. We need to initialize a client, and we need to ask this client, I want to send this message. Something very important, this client is not used only for messaging. This is the example that we did use it here, but this client is used for every single thing outside of your microservice. It could be used for sending messages. It could be used for managing the state for you, for connecting for outside DBs, for connecting even to invoke other microservices. So,
okay, so our solution here is Dapr. So it's a project originally developed by Microsoft. High five to our friend there. That has been developed by Microsoft, and it has been graduated from CNCF in October 24, so it's still recent. And in our case, in microservices architecture, it's really the glue for a seamless integration. So in fact, Dapr is the only library that you will need to incorporate in your application. It is available in many languages, Python, Node.js, Go, Java, PHP. And your application will make HTTP or gRPC calls to the Dapr daemon. The Dapr daemon is started with as code configurations that makes the link between abstract components and the real implementation behind it. For example, for a pub sub component, you will declare the abstract component and say, okay, the real implementation behind it is AWS SNS SQS. For state management, you could create a state management component and say, okay, the backend behind it is Redis. It supports Azure, AWS, GCP, and as always with open source, the only part missing is the one you haven't added yet.
So technically, what's happening under the hood? So I think while we are in the Kubernetes community day, everyone is familiar with the Dapr sidecar pattern. Simply, the sidecar pattern is another process. Basically, if you're working on Kubernetes, it's another container inside your pod, which has a specific process, which has a specific goal related to the processing of your application itself. As you can see in Dapr, there is a Dapr sidecar, which exposes a set of APIs for you in order to give you the option. As you can see in the catalog here, we've got a set of API endpoints to do some external processes. Like, for example, to invoke another microservice, to communicate with another microservice, you can go with the invoke post request. To manage the state, you can go with the state and the publish, and there is a long list, actually, that you can use using Dapr sidecar. Add to that, I want to mention something very important. In microservices in general, we've got two strategies of communication, the push-based and the pull-based. Basically, the pull-based is the messaging one, the push-based is like the REST API one. And as you can see here, Dapr is simplifying the communication strategy. We've got only one, which is the push-based. And in this way, as Jeremy did mention already, we are minimizing the surface of attack because we've got only one interface, which is using the push-based approach. So basically, those push-based are going to be managed by Dapr daemon, and Dapr daemon going to look for the component that you did choose. As you can see here, the definition of a component simply is an entity in Dapr that connects application to external system, which has for goal to simplify the management and the integration of the different microservices in between. So we've got multiple types of microservices, of components, as you can see here, and you can initialize one or multiple component, even if of the same type of component. And even if they are, there is no support for your component or tool out of the box, you can create it. Basically, if you are in Kubernetes environment, you can use CRDs, and it's open for extension.
Let's take a quick example. If we have a look at the pub sub, your application will make an HTTP API call to Dappr's sidecar. And whether you are using RabbitMQ, Redis, Azure Service Bus, the API call will stay the same. It is only the Dapr component configuration that will change. If we take another example, similarly for secrets management, your application will make an HTTP call to Dapr secrets API, and this call will not change no matter the provider you are using behind. It could be AWS Secrets Manager, Azure Key Vault, Kubernetes Secrets. It is only the configuration of the Dapr component that will change.
So let's migrate. You remember actually the architecture of the application, of the e-commerce application that we did present at the in the first slide. This is how we are going to deploy it actually using Dapr. We've got a sidecar. Now we don't have a specific configuration related to each microservice. We've got Dapr, which has for role the management of all the tooling, external tooling application for us. So we are going to deploy this application, starting off by the on-premises.
We'll start by deploying our microservices on-premises using Docker Compose. In a traditional way, each microservices will need to have the specific libraries to connect to Redis, to connect to external services. With Dapr, the microservices is only communicating with Dapr. Okay?
Okay. Now the same application, we did take the same release version actually, if I may say that, the same code base, and we are going to deploy it on now AWS. The only thing that we need to change is that we need to deploy other components, which is in Dapr layer. It's not related to the application at all. It's the same code base that Jeremy did deploy locally actually. And we need to deploy two components, which is one for Amazon SNS SQS and one for Amazon Secret Manager, which is already supported out of the box by Dapr. And we need to create the EKS cluster and install Dapr in it. And we are going to deploy the exact same release version, the exact same code base.
Moving to Azure, no issue. You will just change the Dapr's component configuration, so basically YAML files, by changing to Azure Key Vault for secret management and by changing to Azure Service Bus for messaging, and the application code remains unchanged there also.
And the funny part?
Here is where it gets really interesting. Imagine for regulatory purposes, you have to run the article microservice on Azure and the orders and payment microservices on AWS. Dapr makes it trivial to do so. Why? Because you can have, each microservice can have its own Dapr's component configurations, allowing for a true multi-cloud deployment without having to change the code base.
So actually I want to add the last point here, that we are dealing all the time with Dapr and not the provider and not the platform itself, not the infrastructure itself. Thank you for your attention, everyone. You've got the QR code actually for our SNS profile, and hope you liked it. Thank you.